Hey folks, my name's Micah and I'm a JavaScript developer and I want to share with you what I've been working on. So about 3 months ago I was looking at installing solar panels on my roof but really struggled. I didn't know the dimensions of my roof and I didn't have a measuring tape long enough to be able to measure it. It also didn't help that I was scared of heights and so getting the surface area was a bit difficult. And this got me thinking, what if I could just use Google Maps to work out the dimensions for me? But why stop there? Why don't I just build an algorithm that could work out how many panels would fit too, and how hard could that be, right? So, 3 months later, a couple of scholarly articles on packing two dimensional polygons absorbed, a crash course in computational theory, close to 300 hours of effort, about 800 lines of logic, and three complete rebuilds. I have finally something, while still unfinished. I'm confident this has the math pretty close to figured out now. So let me show you how it works by drawing some panels on a building. I'm going to use our council house as my test subject because it's a really nice building, and if you've never visited it, you really should. It's very pretty. So it's council house B1 1BB. So how this works is you literally just draw a shape around the part of the roof where you want the panels to go, and you can avoid objects, things like chimneys and stuff like that. And so once I've drawn that, I just pick which direction the panels are going to be facing, and it will draw where the panels fit. So I don't really have an elegant way to be able to reset the map at the moment, so I'm just going to refresh the page. So let's go back to the council house again. So council house B1 1BB, and let's pick a different area of the roof. So let's pick this side here. This is a smaller shape. Let's pick this here, and let's say that the panels all face this way. So that's I think they could probably fit one more. There's probably a rounding error there, but it's pretty close. Let's pick another part of the roof. So again, council house B1 1BB. This looks like a nice spot for solar panel. So let's draw a box around there. Pick which way the panels will be facing. Yeah, it looks pretty close. Okay, one last time. Let's pick the council house B1 1BB, and let's pick a different side, and let's pick a different shape as well. So let's pick this side here. So that's a triangle, and it's going to be facing this way. Yeah, it looks pretty close to me. So as I said, this is the third rebuild. On the first, I would think I was pretty naive about some of the mechanics and challenges in solving a problem like this. The computation took way too long and could only handle roofs being drawn in clockwise fashion. The second rebuild fixed these problems, but was limited to shapes that only had between 3 and 4 corners and wasn't very good at handling trapezoids. And so this third iteration can handle any number of corners, and while it's still a little bit buggy with some edge cases and some rounding errors sometimes, it can handle both convex and concave shapes and performs the calculations pretty fast. The general idea here is not that it gives you the perfect measurements, but rather that it gives you a rough idea very quickly with very little effort. I think my next steps will be to build a mechanism to capture details when the algorithm doesn't perform as it should. It definitely needs a lot more polish, so things like resetting the map or adding multiple parts of the roof at the same time so you can measure them all together. I think I'm going to have to spend some time in trying to develop a strategy on how I'm going to monetize this so it's worth my time to continue to develop it. Perhaps build an API so it can be used by third parties. And really get it into a stage where it's ready for people to be able to beta test it and actually see how it works in real life. And so that's what I've been working on. If you've got any comments or questions, just leave a comment.